So in this segment, we are going to solve a few questions based on speed, distance and time. Let's look at the first question. A man traveled 300 kilometers by train and 200 kilometers by taxi. Okay. And it took him 5 hours 30 minutes. So let us quickly note this down. He traveled 300 kilometers by train and then he traveled 200 kilometers by taxi, right? So this distance was covered by taxi. So these 200 kilometers were covered by taxi. And the total time that it took was 5 hours 30 minutes, which basically can be written as 5.5 hours, right? So this is 5.5 hours. And but if we travel 260 kilometers by train, so let's make that diagram now. If we travel 260 kilometers by train, so a slightly lesser distance by train, so this is 260 kilometers. If we travel 260 kilometers by train and then 240 kilometers by taxi, so if we travel slightly more distance by taxi now, then it would take him 6 minutes more. So basically this is going to be 5 hours and 36 minutes, right? This is 5 hours and 36 minutes. Okay, so now we need to find the speed of the train and taxi. Those are going to be our variables. So let's assign the variables first. Let's say, let the speed of the taxi, let the speed of taxi, let the speed of the taxi be say x, and speed of the train be y, right? So these are the two variables that I have assigned. So basically what we are saying is, in this duration, 300 kilometers is by train. I am traveling at a speed of y, and 200 kilometers is by taxi and I am traveling at a speed of x. Similarly, 260 kilometers I am traveling at a speed of y, whereas this is 240 kilometers I am traveling at a speed of x, right? And the total times are given. So in this case, let us now figure out the individual times. If you think about it, time is distance upon speed, right? The distance is 300 kilometers, the speed is y. So the time taken to travel this distance is going to be 300 divided by y, right? And here the distance is 200 kilometers traveling at a speed of x. So the time taken here will be 200 divided by x. The distance is in kilometers and the speed is in kilometers per hour. Therefore, the time is going to be in hours. So the addition of these two times, that is 300 upon y plus 200 upon x, this total time is given by 5.5 hours. 5.5 is 11 by 2 hours, right? This is my first equation. Then secondly, I am covering 260 kilometers at a speed of y. So the time in this case is going to be 260 upon y. And to cover 240 kilometers at x kilometers per hour, it is going to be 240 by x. The time is 5 hours 36 minutes. So what I can now do is, I can convert this into hours and minutes, right? 36 minutes is going to be 3/5 of an hour. So this is 5/3 by 5 hours. That is 25 plus 3, that's 28 upon 5. So the second equation that I will get is 260 divided by y plus 240 divided by x. 240 divided by x. This is going to be 5/3 by 5 is going to be 28 upon 5, right? So this is going to be 28 divided by 5, and this is now my second equation. So now I am going to solve these two equations simultaneously. I think we know of some good substitutions to take care of this. So let us apply the first substitution. The first substitution would be 1 by x. So I can say let 1 by x, let 1 upon x be equal to say a, and 1 upon y be equal to b. I'm sorry about this. So let 1 by x be a and let 1 by y be equal to b, right? So let 1 by y be equal to b. Therefore, what I get is 300b plus 200a is equal to 11 by 2. And the second equation that I will get is 260b plus 240a is equal to 28 upon 5, right? So these are the two equations that I should solve. And now I know how to solve this. I am going to first solve for a and b. And once I get the values of a and b, I will solve for x and y. So let me make some space over here. Before that, I am going to pause for a few seconds for you to take a look at what was done, and then I will go ahead and clear up some space and solve these two equations. Okay, so now let us create some space to solve this particular question. Okay, let me clear up some space. So now these are my equations. Let me mark my equations with 1 and 2. With 3 and 4, I already have used 1 and 2. So now let me decide to eliminate a. I will multiply the third equation by 6. So I get 1200a plus 1800b is equal to 11 by 2 into 6 is 33, right? This is 33. And let me multiply the fourth equation by 5. So it becomes 1200a plus 260 into 5 is 1300b is equal to 28 by 5 into 5 is 28, right? And now time for subtraction. So when I subtract a cancels, 1800b minus 1300b is 500b is equal to 5, which means b is equal to 1 by 100, right? Now let's substitute b as 1 by 100 in any of the equations. So I will substitute b as 100. Substitute b as 1 by 100. So substitute b equals 1 by 100 in say the third equation. So what we get is 300b, that would be 300 times 1 by 100 plus 200a. 200a is equal to 11 by 2. Now 300 and 100 cancels 3 times. This goes for subtraction. I get 200a is 11 by 2 minus 3, which is basically 5 by 2. And therefore a becomes 5 by 400, which is 1 by 80, right? So the values of b are 100, b is 100, and b is nothing but 1 upon y. So I get 1 upon y is equal to 1 upon 100, which means y is equal to 100. Similarly, a is 1 upon 80, a is 1 by x. So 1 by x equals 1 by 80, which means that x equals 80, right? And therefore, the speed of the taxi is 80 kilometers per hour and speed of the train is 100 kilometers per hour. So this is how we found the speeds of both train and taxi. And let me pause for a few seconds. Again, the idea is always try to understand the conditions given in your question and then choose what type of equation you want to use. So over here, because the total time was given, I decided to use time equals distance upon speed to frame my equations. Okay, so that is very important. Pausing for a few seconds. Moving on to the next question. A train covered a certain distance at a uniform speed. Okay. So train covered a certain distance at uniform speed. If the train traveled 10 kilometers per hour faster, it would have taken 2 hours less than the scheduled time, right? So if you speed up the train by 10 kilometers per hour, then it is going to take 2 hours less as compared to the scheduled time. Whereas if the train was slower by 10 kilometers per hour, meaning that the speed was say reduced by 10 kilometers per hour, then it would have taken 3 hours more, right, than the scheduled time. We have to find the distance covered by the train. So I believe that this is a very good candidate for forming a table. So let's quickly form a table and understand what conditions are given to us. So let's consider the following table. Let's assume that the routine speed is s and the routine time taken for the journey is t, and therefore we know that the distance is s into t, right? Distance is speed into time. Now if the train traveled 10 kilometers per hour faster, so now I'm considering the case where you are traveling 10 kilometers per hour faster. So the speed would be s plus 10, right? The speed became s plus 10 kilometers per hour. It would have taken 2 hours less than the scheduled time. That is, the time taken would be t minus 2. And therefore the distance is given by s plus 10 times t minus 2, right? The time taken is t minus 2 hours, and therefore the distance would have been s plus 10 multiplied by t minus 2. Now let's see what is the condition given in the next case. If the train was slower by 10 kilometers per hour, that is if the speed was s minus 10, then it would have taken 3 hours more than the scheduled time. That is, the time taken would have been t plus 3, right? And let me write this again. So the time taken would be t plus 3. The time is t plus 3, and therefore the distance covered would be s minus 10 multiplied by t plus 3, right? So now we know that in all these three cases, the distance covered is exactly the same, right? Therefore, there are a few equations that we can write now. We know that the distance in the first case is st. So I can say that st, this is the distance, is also equal to s plus 10 multiplied by t minus 2, right? This will give me the first equation. So opening up the brackets, st will be equal to s into t is st, s into minus 2 is minus 2s, 10 into t is 10t, and 10 into minus 2 is minus 20. So st now cancels, and therefore I get 2s minus 10t is equal to minus 20. Dividing throughout by 2, I get the first equation, which is s minus 5t is equal to minus 10, right? This is my first equation. Now let's take a look at the second equation. See, the distance covered in the case 3 is also equal to the distance covered in case 1, right? Therefore, I can simply state that st is also equal to s minus 10 multiplied by t plus 3, multiplied by t plus 3. Therefore, st will be equal to, let's open the brackets, st plus 3s, negative 10t, negative 30. st cancels, and therefore the second equation that I get is 3s. Shifting the minus 30 to the left hand side, I get 3s minus 10t is equal to 30. This is my second equation. So now what I can do is I can definitely solve these two equations for s and t, right? So I can say solving these two equations for s and t, suppose I want to eliminate t, then I can multiply the first equation by 2. So I get 2s minus 10t is equal to minus 20, and 3s minus 10t is equal to 30. So now when I subtract, this particular negative term turns into a positive term. This becomes negative and this also becomes negative. So 2s minus s is minus s equals minus t plus 10t cancels. So is equal to minus 50, which means s is equal to 50. So therefore I can say that the speed is 50 kilometers per hour. And now let's find time. So if I substitute s as 50, so substitute s equal to 50 in any of the equations. So in say equation 1, I get 50 minus 5t, 50 minus 5t is equal to minus 10, which means t is equal to 12. So the time will be 12 hours, right? The speed is 50 kilometers per hour, 50 kilometers per hour, and the time is 12 hours. Therefore, the total distance covered, that is what is asked here. Total distance covered will be 50 times 12, that is 600 kilometers, right? So the total distance going to be covered is 600 kilometers, which is 50 multiplied by 12. Now let's see if this particular condition satisfies our equation. So speed is 50 and the time is 12. I know that the total distance is 600 kilometers. Let's assume that the train is moving at 10 kilometers per hour faster, which is 50 plus 10 would be 60. Then to cover the same distance, I would take only 10 hours, right? Which is t minus 2. So 60 times 10 is also 600. So this matches. Whereas if I slowed down by 10 kilometers per hour, that is the speed became 40, then the time would be 12 plus 3, which is 15 hours. The total distance again covered would be 40 multiplied by 15, which is again 600 kilometers. So you will see that all these three conditions, they exactly satisfy the given conditions, and therefore our equations are right and our solution is also correct. So let me pause for a minute or so for you to grasp everything that was done here, and then we can continue with the next question. Moving on to the next question. Points A and B are 70 kilometers apart on a highway. A car starts from point A and another car starts from point B, and they meet in 1 hour if they travel towards each other. If the cars travel in the same direction, they meet in 7 hours. Find the speed of the two cars. So I think this is a good time to draw the diagram. Okay, there are 2 points which are 70 kilometers apart on a highway. So let's label these points. So we have the first point here is A. Let's label these points. So this is A and this is B. These are 70 kilometers apart on a highway, right? So this complete distance is 70 kilometers. So let's mark that as well. The complete distance is 70 kilometers. Now, if 2 cars start from point A and point B, so let's label 2 cars. This is car starting from point A and this is the car starting from point B. If these cars travel towards each other, that is, the car at A, it moves towards the right. Okay, so this car moves towards right, and the car at B, say it moves towards left. Then they meet each other in 1 hour, right? So if this car travels in this direction, then after 1 hour, these 2 cars will appear at this point, right? So these 2 cars will meet each other at this particular point, right? And this is after 1 hour of travel. That means, in this case, let us note down a few things. I have to find the speed of the 2 cars. So let's assign the variables. Let the speed of car A, let the speed of car A be x, and let the speed of car Y, let the speed of car B be y, right? So this is the speed of the 2 cars. Now in 1 hour they meet each other, isn't it? That means in 1 hour the distance travelled by car A plus the distance travelled by car B, this total distance is going to be 70 kilometers, right? This is the distance covered by car A, right? This is the distance covered by car A, whereas this is the distance covered by car B. This total distance adds up to 70 kilometers. So the distance is speed into time. The speed of car A, so this is nothing but speed of car A multiplied by the time taken by car A, because distance is speed into time, plus the distance covered by car B will be speed of car B multiplied by the time taken by car B. This has to be 70. So you will notice that in the previous questions I was taking up the total time as the guideline for forming the equation, but here I am using the distance covered by the car as the guideline, right? Therefore, the speed of car A is going to be x. Speed of car A is x. Time taken by car A is 1. Plus speed of car B is going to be y, and time taken by car B is also going to be 1, which equals 70. Therefore, the first equation will be x plus y is equal to 70. Right? This is the first equation. Now, let us look at the second condition that is given. Suppose the cars travel in the same direction. So let me draw a diagram again. So now I have car A which starts from here and car B starts from here, and they move in the same direction. That is, assume that they both move rightwards. Then they will meet each other after 7 hours. That is given to us, right? So this is the complete distance traveled by the car A. Let us label that. This is the complete distance traveled by the car A, and the distance traveled by the car B is this much. The distance between, say, the point B and C. Let's label this as C. So this is the total distance covered by the car B, right? So now I know that because these two cars are meeting at the point C, I can definitely say that the distance covered by car A is equal to, this distance is 70 kilometers, right? This complete distance is 70 kilometers. This distance is 70. The distance between them initially is 70. So distance covered by car A is going to be 70 plus distance covered by car B, right? Now distance covered by car A is nothing but speed of car A. Speed of car A is x, and the time taken to cover this distance is given as 7 hours, right? So it is x into 7 is equal to 70 plus the distance covered by car B. Distance covered by car B will be speed of the car B multiplied by time taken by car B. So what is the speed of car B? Speed of car B right now is y, right? We have taken this as y, and time taken to travel this distance is 7 hours, because it is given that these cars meet after 7 hours. So this is going to be y into 7. Therefore, I can say that 7x is equal to 70 plus 7y. Dividing throughout by 7, I get x equals 10 plus y, right? This is my second equation. So you will notice that in this particular problem, I am using distance covered as the guideline for forming the equation. And again, it is because in this case the distance is given and the time taken multiplied by speed is the distance. Therefore, x plus y equals 70 is when the cars move towards each other, and x is equal to 10 plus y is when the cars move in the same direction, right? And therefore, solving these two equations, I get x equals 40 and y equals 30. So the speed of car A is 40 kilometers per hour, and the speed of car B is 30 kilometers per hour, right? Just to summarize, when they were traveling towards each other, the sum of their distances was the initial distance between them, right? And you can quickly check that in 1 hour A covered 40 kilometers and B covered 30 kilometers, which is why they met each other, as the distance between them was 70 kilometers. While if they move in the same direction, please understand that the distance traveled by car A, so car A starts from here and it first travels 70 kilometers and then it is also traveling the distance covered by car B. That's why distance covered by car A is 70 plus distance covered by car B, and that gave me my second equation, and then I was able to solve for x and y. So just to quickly check, in the second case, B is moving at 30 kilometers per hour, right? And in 7 hours, he will cover 210 kilometers, isn't it? 30 into 7, that's 210. And A on the other hand is moving at 40 kilometers per hour. So 40 into 7 will be 280 kilometers. You will notice that 280 is 70 plus 210. So this perfectly matches the data that we have, and therefore our solution is right. Okay, so pausing for a minute before I move on to the next question. Just take a look at the different strategy that was used in this particular problem. Moving on to the next question. Okay, points A and B are 80 kilometers apart on a highway. A car starts from point A and another car starts from point B, and they meet in 1 hour 20 minutes if they travel towards each other. If the cars travel in the same direction, they meet in 80 hours. Find the speed of the two cars. So again, let's make a nice diagram for both the conditions, and then we will frame our equations. So in the first case, the cars A and B are moving towards each other, and in 1 hour 20 minutes they meet each other, right? Now we have to find the speed of the two cars. So let the speed of the cars be x and y, right? Kilometers per hour. Okay. So let this be the variables that are assigned to speed. Now in 1 hour 20 minutes, so 1 hour 20 minutes should be converted into hours. It is one third of an hour, right? Because 20 minutes basically implies 1/3 of an hour. So 1 hour 20 minutes is 1/3 of an hour, which is in mixed fraction it is 4/3 hours. So now the distance covered in the first case, the distance covered by A is going to be 4 times x by 3, because 4/3 is the time and x is the speed of car A, and the distance covered by car B is going to be 4y by 3. Again, 4/3 is the time and y is the speed. So the distance covered by A and the distance covered by B should add up to 80, because the complete distance between these 2 points is 80 kilometers, right? This is already given to us in the question. So in the case A, when the two cars are moving towards each other, I know that 4x by 3 plus 4y by 3 is equal to 80, and which implies x plus y is equal to 60. So the first equation is x plus y equal to 60, right? Now let's take a look at the second equation. The distance covered by the car A. So car A starts from here, and this is where both the cars meet. They are moving in the same direction. So I can definitely say that the distance covered by the car A, so distance covered by the car A in the second case is going to be, it is moving for 8 hours, right? They meet in 8 hours. So it will be 8x, and the distance covered by car B will be 8 times its speed, that is 8y. Again, because 8 is the time and x is the speed, so speed into time is equal to the distance. So I can say that the distance covered by A, which is 8x, is equal to distance covered by B, which is 8y plus 80. And therefore the second equation is x equals y plus 10, right? This is the second equation that I get. And now I can conclude that from these two equations, if I solve them, I will get x equals 35 and y equals 25. So the speed of car A is 35 kilometers per hour and speed of car B is 25 kilometers per hour, right? So these are the speeds of these two individual cars. And again, let me summarize this particular problem quickly. When the cars were moving towards each other, the distance covered by them, which was 4x by 3 and 4y by 3. How did I come to this conclusion? Because distance covered is speed multiplied by time. In case of A, the speed was x and the time was 4/3 of an hour, because 1 hour 20 minutes is 4/3 of an hour. And similarly, distance covered by B is 4y by 3. So 4x by 3 plus 4y by 3 is equal to 80, right? And therefore this 3 goes for multiplication. So 4x plus 4y is 240, which means x plus y is 60. This is my first equation. And when the cars were moving in the same direction, A started from here, and A first had to cover 80 kilometers, right? A had to first travel 80 kilometers, and then it had to also cover the distance of B to catch up with the car B, right? That is why we have framed distance covered by A which is right over here, which is 8x, is equal to 80 plus the distance covered by the car B. So 8x equals 8y plus 80. I just divided by 8 and I got x equals y plus 10. So this became my second equation, and solving the two simultaneous equations, I got x equals 35 and y equals 25. So this is how I went about this particular question. Let me pause for a minute before I continue with my next question. Okay, moving on to the next question. While covering a distance of 30 kilometers, Ajit takes 2 hours more than Amit. Okay, so let's underline some keywords. Distance is 30 kilometers and initially Ajit takes 2 hours more than Amit. If Ajit doubles his speed, he would take 1 hour less than Amit. So I think there are some conditions given here. It would be a good idea to form a table for this particular question. So let's prepare a nice table. So let's consider the following table. Let Ajit's speed be x, the regular speed, and let Amit's speed be y. So they are covering a distance of 30 kilometers. So if Ajit walks at x kilometers per hour and he is traveling 30 kilometers, then the time taken by Ajit is going to be 30 by x, right? And Amit is walking at a speed of y kilometers per hour. So the time taken by Amit will be 30 upon y, right? Now it is given that Ajit takes 2 hours more than Amit. So time taken by Ajit is 2 hours more than time taken by Amit. Which means 30 upon x, this implies 30 upon x is equal to 2 plus 30 upon y, right? This is my first equation, correct? This is the first equation. Then in the second case, it is said that if Ajit doubles his speed, so let's consider that Ajit's speed is 2x now. So he is doubling his speed. His initial speed was x. Now he has doubled his speed, which means his speed is 2x. Then the time taken by Ajit in this case would be 30 by 2x because his speed is 2x now. Amit's speed remains y. So time taken by Amit is 30 upon y. And now it's given that if Ajit doubles his speed, he would take 1 hour less than Amit. So Ajit will take 1 hour less than Amit. Which means time taken by Ajit is 30 upon 2x will be 30 upon y minus 1, right? So these are the two equations that I have with me now, and I should be solving them simultaneously. Of course, I know the techniques that are required for solving this, but I would still pause for a minute for you to take a look at this table and correlate it with the question that is given above. So now I can make some substitutions, right? I can say let 1 by x be equal to a and 1 by y equal to b. So the equation that I will get is 30a is equal to 2 plus 30b. That's the first equation. And 30 upon 2x is going to be 15 upon x. This term is going to be 15 upon x. So it will be 15a equals 30b minus 1. And now I can subtract these two. So when I subtract these two, 30a minus 15a becomes 15a. And 30b minus 30b cancels. And 2 plus 1, this minus 1 changes to plus 1. So 2 plus 1 becomes 3, which means a equals 3 upon 15, which is 1 by 5. But what was the value of a? The value of a was 1 by x, which means I can say that because a is 1 by 5, 1 by x is also equal to 1 by 5, which implies that x is equal to 5, right? And now I can substitute x as 5 here. So let's substitute x equals 5. 30 upon 5 is 6. So 6 equals 2 plus 30 upon y. So if you solve this equation, 6 minus 2 is 4. So 4 equals 30 upon y, which means y is equal to 30 upon 4, which is 7.5. So I can say that Ajit is moving at 5 kilometers per hour. That is his speed, and Amit is moving at 7.5 kilometers per hour, right? These are their individual speeds. So again, I will pause for a minute, just take a look at the different conditions, and I use the simple idea of substitution to get the variable in the numerator, and this is how I solve for x and y. And I'll pause for a minute and then we conclude today's session.